For decades, scientists believed Jupiter was one of the best understood planets in planetary science. As the largest planet in our solar system, Jupiter became a reference point for understanding how giant planets form, how planetary systems evolve, and how similar worlds may have emerged across the universe billions of years ago. There was only one problem. When NASA finally looked closer, Jupiter began telling a completely different story. And suddenly, one disturbing possibility emerged. We may have fundamentally misunderstood one of the most important planets in astronomy. Jupiter formed roughly 4.6 billion years ago, during the earliest stages of our solar system. Because it formed so early, astronomers believed the planet preserved a record of how giant planets are born. Over time, that belief became deeply embedded in modern astronomy. Researchers eventually began treating Jupiter as one of the primary models for understanding how giant planets form. Even today, thousands of giant exoplanets discovered around distant stars are interpreted using models heavily influenced by what Jupiter seemed to reveal. For decades, this picture felt remarkably stable, which is exactly why what happened next became so unsettling. In 2016, the spacecraft Juno entered orbit around Jupiter with a mission that seemed straightforward. The mission was expected to confirm ideas scientists had trusted for decades. According to accepted models, Jupiter should contain a dense central core left behind during the earliest stages of its formation. That was the expectation. But once Juno began measuring Jupiter's gravitational field, the data immediately created a problem. Instead of confirming a compact internal core, the measurements suggested Jupiter may contain what scientists now describe as a diluted or fuzzy core structure. Later, mission scientist Scott Bolton admitted the mission was forcing researchers to rethink Jupiter almost entirely. And this was only the beginning. The first anomaly was Jupiter's internal structure itself. Planetary scientists had long assumed giant planets formed around stable, dense cores. Yet Juno's measurements led some researchers to propose that an enormous collision early in Jupiter's history may help explain its unusual internal structure. Then came a second anomaly. Near Jupiter's poles, Juno discovered enormous cyclonic structures arranged in highly organized geometric patterns. Storm systems this large are naturally unstable. Over time, scientists expected them to shift position, interact with each other, and gradually break apart. But years later, these storms remained almost exactly where scientists first observed them. That was deeply unusual. Structures this unstable should begin shifting over time. Instead, repeated observations kept revealing the same extraordinary level of stability. And then, scientists encountered a third contradiction. Jupiter radiates significantly more heat than it receives from the Sun. For decades, researchers believed slow gravitational compression explained this excess heat. But Juno's data suggests the planet's internal behavior may be far more complex than those models assumed. Of course, not every researcher sees this as a crisis. Some scientists believe future observations may eventually explain these anomalies without overturning existing models. But after years of measurements, the contradictions continue accumulating. It was as if scientists had opened a machine they believed they fully understood, only to discover parts inside that were never supposed to exist. For Scott Bolton and the team behind Juno, these discoveries carry weight far beyond scientific curiosity. Every close flyby forces the spacecraft through one of the harshest environments anywhere in the solar system. Jupiter's radiation is so extreme that NASA had to seal Juno's sensitive electronics inside a titanium vault designed to keep the spacecraft alive. And once Juno enters those regions, there is very little anyone on Earth can do. For several long minutes, years of engineering depend entirely on whether a signal eventually returns. For the engineers behind Juno, every returning signal brings the same sense of relief. It means the spacecraft survived once again, and another piece of Jupiter's mystery can finally be brought back to Earth. Yet somewhere inside that violent environment, a machine built by human hands continues collecting data that may be forcing scientists to rewrite one of planetary science's most trusted theories. Years after entering orbit, Juno continues sending back discoveries scientists still struggle to fully explain. Why do Jupiter's polar cyclones remain stable for so long? What exactly disrupted the planet's internal structure billions of years ago? And why does Jupiter continue radiating more heat than existing models can fully explain? Future analysis may eventually provide answers, and with every orbit completed, scientists are reminded of one uncomfortable possibility. Jupiter may still be hiding discoveries nobody has even imagined yet. For now, some of its most important mysteries remain unresolved, and history suggests moments like these rarely end where science expects. At the beginning of this story, Jupiter represented certainty. It was the planet scientists believed they understood better than almost anything else in our solar system. But after everything Juno has revealed, that confidence no longer feels as solid as it once did. For decades, science treated Jupiter as a blueprint for understanding how giant planets form across the universe. But if one of the most studied planets in astronomy has been misunderstood all this time, then some of the assumptions scientists use to understand giant planets may need to be reconsidered. The universe has always done this to us. The moment we begin believing we finally understand reality, reality reminds us that we understood far less than we ever imagined.